Welcome back. We're getting our first look at LeChatelier's principle in here. And they give us some systems and stresses, and they're going to ask us what happens. So anytime you have an equilibrium system like this, at some point the system's going to settle down, get to its equilibrium, and be happy. And that's where we assume we're starting when we have a system like this. It got to equilibrium. It's got all of its concentrations in such a way that its Q equals KEQ. So it's feeling good about its balance of products and reactants. And now we're going to mess it up. We're going to apply what LeChatelier called a stress, and we'll see what the system does in response. The first stress, they say, is what would happen if you added dichromate ion to the above system. So the system's sitting there, it's all good, and then we do that. This means we increase the concentration of Cr2O7, which screws up the system. It was at equilibrium, now it's not. And what LeChatelier's principle says is whenever you do this, the system is going to fight back and try to cancel out whatever stress you just applied. If you add dichromate, the system is going to fight back and use up dichromate because it's trying to remove the extra that you added. Now, when you add dichromate, if you're using up a product like this, you have to use up all the products at the same time. So H2O will also go down, and if the right side is going down, the left side must be going up. So the rules are you're going to draw arrows under every species. Every side has to go down as a team, so the entire right side goes down together. The entire left side goes up together, and you have to do this in such a way that it cancels the original stress. Every time I draw these, unless I forget, I will make the stress a red arrow, and then all the system response will be a blue arrow. So we do this to mess up the system. The system does all these blue things trying to cancel us out. So when they say what would happen, the long answer is chromate ion will go up, hydrogen ion will go up, dichromate ion will go down, and water will go down. The short version is the equilibrium will go left, or the system will go left, producing more left side stuff as it tries to cancel this stress. Good. Let's get some reps in here. Okay, question B. What would happen if you added hydrochloric acid to the above system? Well, you look at this and first you panic and say, I don't see hydrochloric acid, but hydrochloric acid dissolves into chloride ions, which we don't care about. They aren't in here, and hydrogen ions. So adding hydrochloric acid is equivalent to adding hydrogen. What does the system do? It sees extra hydrogen and says, oh no, you don't. I'm going to cancel that out. If this left side thing is going down, then the whole left side must be going down, and if left is going down, then right must be going up. So your stress is add hydrogen, the system response is use up hydrogen, and in the process it does these other things as well. So you could, again, list those one by one, or the short answer will be the system will shift right. It'll make more right side stuff in the process of canceling out your stress. This next one is iron reacting with the thiocyanide ion, and making iron thiocyanide. Is that thiocyanate? Rats. Sorry about that. Thiocyanate is SCN. Don't see that very often, so I am rusty on it. Okay, so same idea. It's an equilibrium. It has a left side, it has a right side. If we add KSCN to this system, first of all, you don't see KSCN in there, but assuming this dissolves, and potassium compounds usually do, we'll get potassium ions, which don't interest us. They aren't in the reaction. And we'll get thiocyanate ions, SCN. So this goes up. That's our stress. And the system always resists whatever stress we put on, so the system will do that. If left side's going down, the whole left side has to go down together, and if left is going down, right must be going up. So the stress was this one, and the system response is left side goes down, right side goes up, or the short version is the system shifts right. Okay, so some of these, the challenge is figuring out what their cryptic stress is. Sometimes they're straightforward and they say we're adding dichromate, that's easy. Some of them you have to think about what would this substance do when it dissolves, what ions does it produce, and this last one is the trickiest of all. This one's unusually hard. I actually kind of stumbled on this one the first time I ever saw it, but you're probably going to do better than that. What would happen if NaOH were dissolved in the equilibrium mixture? So the thought process is NaOH. First of all, that's not a product or a reactant in our equation, so we need to think a little deeper. If this dissolves in water, we get sodium ions and hydroxide ions. Those aren't in the reaction either, so we have to think a little deeper apparently. Would either of these things react with any of these things in some way and change one of them? If you meditate on that, and if you remember your solubility table, the important thing that you'll eventually find is iron hydroxide, this, has low solubility, meaning it forms a solid. That means if there's hydroxides floating around with iron 3, hydroxides will occasionally lock onto an iron 3, turn it solid, and that pulls it out of solution. You don't have this ion anymore because it turned into a solid little chunk and sank to the bottom. So adding NaOH has the effect of pulling iron out of the solution. These irons get married, they react with a hydroxide, and then they go away and you don't see them anymore. So that's our stress. Tricky, but adding this removes iron. And when we in a system say iron is removed from the solution, it's usually some kind of trick like this that we're actually doing. So if we've removed iron from the system, what does the system do? It says, nope, I'm going to replace that iron you stole from me. If I'm adding left side stuff, I have to add all the left side stuff together. And if I'm making left side stuff, it must be at the cost of right side stuff. So the system is going to shift left to cancel out that stress. Good so far?